Hello guys, in today's episode. Today I want to show you a pretty simple thing that I have built with my friend a few days ago. And this is just a very simple light or alarm, sound light alarm, which works pretty simple. Here I have 12 volt LED and it shines up, as you can see, this LED when I pull the other one closer. Of course, I can connect the buzzer to it, and it's a bit more annoying, but it works. So, mainly, we have only a few components in here. We have buzzer, we have 2 resistors, 1 potentiometer, 1 LM386 op-amp, photo transistor, a single LED, and I am just connecting my power supply to it. So how it is working. So let's now see what our photo transistor outputs. It has 3.5 volts. As you can see, we are supplying 9 volts and we have 3.5 volts on the photo transistor. And when I pull it close, it outputs 0.1. Let me disconnect the buzzer. When I pull it closer, it outputs, as you can see, 0.8 volts, and then it supplies the voltage. So if we will connect the buzzer directly to it, it will buzz all the time and then turn off when we put the light close, but we want to have to reverse it, to reverse this effect. So what we are doing here is we are connecting an op-amp in here. I will show schematic a bit more later. To the inverting input of the op-amp, we connect our photo transistor output, and to the inverting input, we connect the potentiometer. So we can change the threshold voltage when we output the voltage on the output to buzz the buzzer or turn on the LED. So this is just like a sensitivity knob. And then to the output we have connected the LED that indicates it in more visual way, and here we have the buzzer which visualizes it in a bit more sound way. So this is mainly the whole working principle. As you can see, the red LED lights up when I pull the light close. And now see the output. The output is pretty low, but when I bring the light close, it pulls it up to newly the supply voltage, 8.2 volts, which is pretty high because we are supplying 9 volts to the circuit. So let's now see the schematic. Schematic looks pretty much like that. So we got our VCC, which in our case is 9 volts. We pass it through a little resistor to the photo transistor, and then we connect it to the inverting input of the op-amp. And the op-amp amplifies the difference between the pins. And the difference between the pins. Here we have the sensitivity switch, because when we have the inverting input and the plus input, when the inverting input is lower than non-inverting input, it amplifies the signal, which in our case it just pulls the output of the op-amp to the VCC voltage. Here we have the power supply connected, and here we have the voltage divider built on the potentiometer. Here we have the LED and the buzzer connected. So this is pretty much the whole thing that I have built. You need to keep in mind the polarization of the power supply of the LM386, because when you connect it one time in reverse, it will be overheating all the time after this mistake. So you need to keep this in mind. And of course, if you don't have the buzzer that generates its own signal, you can just put the transistor in here on the output, some kind of MOSFET, and a generator, for example, output, connect to the collector of this transistor, and then to the emitter you can connect the buzzer if you don't have buzzer with internal oscillator. So that's pretty much it. I can show you the reference voltage level. So this is the meter, and this is the transistor output, and this is the reference voltage for the op-amp created by the potentiometer. So here we have 3.2 volts, and here we have 3.4 volts, and when it drops down lower than 3.2 volts, the output of the op-amp is connected to the supply voltage. So it's pretty simple. That's how you can use op-amps in the configuration of comparators in your circuits. Of course, you can use a bit different stuff in here. Mainly you can use, instead of this IC, you can use inverter, but in this case you can use just the op-amp, and the pinout is pretty simple of the IC if you need to know. Here we have the pinout of the op-amp. Here we connect our transistor, which is the inverting input. To the non-inverting input we connect our reference voltage created by the potentiometer. Here we connect ground, here we connect supply voltage, and here we have our simple output. And that's pretty much about wraps it up for this episode. This was pretty quick, but I hope it was interesting for you. Maybe you will build something like that by yourself, or even build a more advanced configuration of the circuit with some generator in here, and generate some kind of frequency with 555 timer, and then connect it to the buzzer. So that was, I hope, interesting for you and constructive. So see you in the next video. If you want to see more videos like that, you can visit my website ardugeek.pl.